All right, let's tackle an interesting question that combines many of the concepts we have seen lately. So it is question 231. Let's read the question. Question 31. The rod is initially at rest. Upon release, the rod will accelerate to a final velocity. There is no friction between the rod and the rail. The electrical resistance of the rod and rail is negligible. Given the distance between the rail to be 0.6 meter, the mass of the rod to be 0.1 kilogram, and the magnetic field to be 0.2 Tesla, calculate the maximum velocity of the rod. So we are given a diagram. Basically, we have two rails, and they are against gravity, so they're pointing upward. There's a resistance connecting the top. Basically, that resistance is like the equivalent resistance of the complete circuit. We are given that this section is 0, so that will be the resistance preventing the current from becoming too high. We have a magnetic field that is pointing outward, all right? Now, what's happening is we have this rod, and it's falling down due to the force of gravity. And there's a point where it will reach the maximum velocity. At this point, it means that if it reach a maximum velocity, it means that the acceleration on the rod becomes 0 because the magnetic force and the force of gravity cancel each other out. So once the rod starts falling down, the area is increasing. The number of field lines going out of the body is increasing, which means that our closed loop will react by creating a magnetic field inside, pointing into the board. That will create a current going clockwise, and if we point, so that means the current will go that way. We point our finger toward the side of the current, curl our finger toward the magnetic field, and the force will be pointing upward. So we do have a magnetic force that will counteract the force of gravity, and it makes sense. If in the beginning, really, what's accelerating the rod itself is the force of gravity, so it's only normal that the magnetic force will counteract that force by Newton's third law. All right, so we got a couple of values. So the mass is 0.1 kilogram, the magnetic field is 0.2 Tesla, the resistance is 1 ohm. We got this expression for the magnetic field force on a current carrying wire. So the rod can be considered a current carrying wire. It is falling due to gravity. The force on the current carrying wire is equal to the magnetic field multiplied by the length of the wire. In this case, it will be the same length as the distance between the two rails multiplied by the current. Now note, by Ohm's law, the current will be equal to the electromotive force divided by the resistance. Well, the resistance is simply 1, therefore the current and electromotive force will be the same. We could, if we wanted to, replace already the I over here with the electromotive force. Okay, we've seen in the previous video that the electromotive force in this type of diagram, this type of circuit, is equal to the magnetic field multiplied by the velocity multiplied by the length. Note, this velocity will be the maximum velocity when the two forces cancel out. So let's just get a simplified formula for the magnetic force. We replace the electromotive force, the current by the electromotive force, and we replace the electromotive force with this term. So magnetic force is equal to magnetic field multiplied by the length, multiplied by the magnetic field, multiplied by the velocity, multiplied by the length. We simplify B squared L squared multiplied by V. All right? Now at this point, we know that when the rod starts falling, it will eventually reach a maximum velocity. At that point, the magnetic force and the force of gravity, both of them has to be equal. So Fm is equal to mg, force of gravity, mass times gravitational acceleration. That's it. So B squared L squared V, this is the value we're looking for, is equal to mg. We simply isolate the V over here. We got velocity is equal to the mass times the gravitational acceleration divided by the magnetic field square multiplied by the length square, and we get 68.05 meters per second. I think it's an interesting question. There's many different parts that combine a bit of everything. You can be sure that in the final there will be some question that combine many concepts together, and this is done to make sure that you truly understand each concept. All right, this is a very good example of such question. All right, So let's move to a few more example regarding generator, and we are almost done with this chapter. See you in the next video.